Today we're going to start chapter 5, the first section which is on trigonometric identities. So an identity is when in an equation both the left and right sides are equal to each other. So a trigonometric identity is when both the right and left side of an trig function are identical or are the same. So we talked about that cosecant was the same as 1 over sine earlier. But what's also true is that sine is 1 over cosecant. So these right here, which we've had all along, are going to show up again. And these are going to actually help us solve some sort of trig problems later on. Cosine is 1 over secant, just like secant is 1 over cosine. Tangent's 1 over cotangent, cotangent's 1 over tangent. Okay? And so just remember that tangent is sine over cosine, and cotangent is just the opposite, cosine over sine. Now you can use these to find some trig values that we'll look at now. First example, A, says if cosecant of theta is 7 over 4, find sine of theta. Well, we know sine of theta is just 1 over cosecant of theta. Well, since cosecant of theta is 7 over 4, I'm just going to plug in 7 over 4. So sine of theta is going to be 1 over 7 over 4, which reduces to 4/7. So sine of theta is going to be equal to 4/7. Easy enough, right? Just the reciprocal. Next one, it says if cotangent of x is 2 over 5 square roots of 5, and sine of is 5 square roots of, the square root of 5 over 3, find cosine of x. Well, we know that cotangent of x is going to be cosine of x over sine of x, correct? Because tangent is sine over cosine. Cotangent is cosine over sine. So we know that this is 2 over 5 square roots of 5. And then we have some cosine of x. And that's going to be equal to the square root of 5 over 3. So if we want to get cosine of x all by itself, we need to undo the dividing by the square root of 5 over 3. So I'm going to multiply both sides by the square root of 5 over 3. And multiply this side by the square root of 5 over 3. So square root of 5 times 2 on top would be 2 square roots of 5. And then on the bottom, 3 times 5 square root of 5 would be 15 square roots of 5. Now you'll notice that both of them have a square root of 5 in them. So those two cancel out. And so cosine of x, cosine of x in this problem is just going to be 2. Here's a couple guided practice problems. Feel free to try those. Now, we also have what are called the Pythagorean identities, and they go back to what we know about trigonometry and circle information. It says sine squared plus cosine squared always equals 1. Tangent squared plus 1 is always equal to secant squared, and cotangent squared plus 1 is going to be equal to cosecant squared. Just a note, remember when they write it cosine squared of theta, it's really meaning the value of cosine, that quantity squared. Okay, same with tangent squared and so on and so forth. Alright, so example 2. It says if tangent of theta is equal to -8, find, and sine of theta is greater than 0, find sine of theta and cosine of theta. Well, first off, we know that from our trig identities above, that tangent squared of theta plus 1 is equal to secant squared of theta, right? Well, the nice thing is that if we can find what secant is, we can use that information to find what cosine is, because they are reciprocals of each other. So tangent squared of theta. So tangent of theta is -8. So I'd have to square that. Plus 1 is going to be equal to secant squared of theta. -8 squared is 64, plus 1 is 65. So now I know that secant squared of theta is equal to 65. So to figure out what secant is, I'm going to take the square root of both sides. So secant of theta is going to be equal to the square root of 65. Now we're trying to find cosine. So that doesn't help us right now. But we do know that secant is the same as 1 over cosine. Okay? So we can say that 1 over cosine of theta is equal to the square root of 65. Right? So if 1 over cosine of theta is equal to 65 over 1, reciprocal of each other, cosine of theta is going to be equal to 1 over the square root of 65. And you'll remember that we don't like to have square roots in the bottom. So I multiply the top and bottom by the square root of 65. And I find that cosine of theta is equal to the square root of 65 over 65. There's my first one. Now, to find sine, well, the nice thing is that remember tangent right here is going to be equal to sine over cosine. So we'll write that. Tangent of theta is equal to sine of theta over cosine of theta. So, since that is negative 8, tangent is negative 8, and we don't know sine of theta, but cosine of theta is the square root of 65 over 65. I can multiply both sides by square root of 65 over 65 to find my answer of sine of theta being negative 8 square roots of 65 over 65. And actually earlier it said that it's going to be greater than 0. So since this is negative, we can make it positive because when we took the square root of this earlier, right here, this could be plus or minus. So there we are. And we could check our answers if we wanted to, but for the sake of time, we will not. Here's some guided practice. You can try these as well. Again, here are the Pythagorean theorem, or the Pythagorean identities. Okay, so the last thing we're going to talk about is cofunction. And so a cofunction is when you have identities that are similar and can be represented as other trig identities and can be moved apart from each other. So remember, sine of theta is the same as cosine of pi over 2 minus theta. And so all of these show up and can help us for later on to solve certain identities. We also have odd and even identities. So sine of a negative angle is the same as the negative sine of that angle. Just like the cosine of a negative angle, notice it's the same as the cosine of the positive angle. And so odd and even identities show up a little bit later as well. Now we're not going to look at an example of those two, but they're good for your information later on. Now the last example we're going to look at is example 4. And we want to rewrite this whole thing, but only using sines and cosines. So, if I'm going to write this, cosecant is the same as 1 over sine of theta. We know that as an identity. And secant is the same as 1 over cosine of theta. And cotangent, I'm going to rewrite. Remember, cotangent is cosine of theta over sine of theta. Now, if I simplify the first part, I just get sine over theta, cosine theta. Okay, sine theta, cosine theta, minus. And now if you want to ever add or subtract, you have to have a common denominator. So I need to multiply this top and bottom right here by cosine of theta. Now why do I do that? Because now I have cosine squared of theta on top and sine squared, cosine squared, or cosine theta on the bottom. Now notice, this and this are the same. So I can rewrite it with 1 minus cosine squared on top and sine squared, sine theta, cosine theta. And so I look at those. And I think back to, are any of those any of our identities? Well, if you look back to earlier, you'll see that 1 minus cosine squared is the same as sine squared of theta. So this thing right here is actually the same as sine squared of theta. So I'm going to rewrite that as sine squared theta over sine of theta cosine of theta. And so we said, okay, well sine squared is the same as sine times sine. And there's a sign down here, so I can cancel this out, cancel the square out, and so I end up getting sine theta over cosine theta. So there's my answer. Another way to write that would be tangent, because tangent is sine over cosine. So an important thing to add to your notes is this right here. That sine squared of theta is equal to 1 minus cosine squared of theta. That's an important thing to add to your notes. As well as cosine squared of theta is equal to 1 minus sine squared of theta. And that goes back to our Pythagorean identities.